them really fast, so you guys have time for Recursion 2. Okay? So, can everybody see my screen? Dope. All right, so let's do the first question, which is, what is it? Count vowels. Count vowels is actually a lot like the question I showed you in the lecture, which is where I was concatenating a string that only returned the consonants. When I say it's kind of the same thing, I mean it's because we're working with strings. And the base case was the same, right? And we were doing this other function down here as a helper function, right? Which takes a character and it returns if this is a vowel or not. So we could just return a-i-o-u dot index of car dot to lowercase. Return if this is equal, if this is not equal to -1. So if it's not in here, that means it's a consonant. So if it's not in here, it will be -1. So this will return false if it is not a vowel. If it is a vowel, it will be anything other than -1, so it will return true. And I'll just write this now to get it out of the way, right? Because we know we're going to need it. So this is going to take a string, and basically we want to do this with recursion, right? So what's the first step? What is your base case? If we know that we're going to be returning, so this is a little different, right? So I said usually the function and the base case should be returning the same thing, right? So we know that we're going to be returning a number, right? Because we're going to have like a let total equals 0. So since this is the thing, since we're going to be returning a number of vowels, your base case should be returning this as well. However, so we can just say if something return 0, right? So if what though? Since we're still looping through a string, it should still be if string dot length is equal to 0. Or I can just do if bang string dot length, right? So if bang string dot length, we are going to return something. Otherwise, we have to do our recursive case. So what is that? We have another if statement here, and we say if is vowel, and what are we going to pass in? We are still going to pass in string of 0, right? Just like the example I did. So if the first character, if that is a vowel, then I will do total plus equals 1, right? Because we found a vowel. If it's not a vowel, we skip this. We skip this increment. Now that we checked the first letter, we have to check the rest of them without looping, right? So we can do total plus equals count vowels, and what do we pass in? We have to make this base case eventually be hit, so we have to decrement the length. Since we checked the first character, we don't want to check it again, so let's slice that off and go until the end by passing in 1. So now we say total is going to plus equals count vowels passed in string.slice of 1. Then, at the end, we can return total. And here is your solution. Any questions on count vowels?
So in the first conditional, you say return 0. If I had return total, would that not?
This would be fine as well, only because, let's say I passed in an empty string here, right?
Mm-hmm.
The first thing I do is I define total, and total is 0.
Right.
I increment total down here, but if this base case is ever hit, we just return total right away. So we never increment it ever. So total will always be 0 at this point.
Right.
So you can do that. But if you decided to, let's say, define this later, then you would have to say 0, right? But it's the same thing.
I had to let total equal 0, and I had, return total.
Mm-hmm. This is the same thing, for sure. And we can clean this up a little bit. Right.
Okay. Yeah, I was so close.
Any other questions? All right.
Wait, why does the if statement have exclamation point in front of string length?
Because if statements coerce whatever's inside them into booleans, right? So when is the length property of a string ever going to be falsy? Because bang falsy will make it true, right? It's when the length is 0. So this is another way of saying is equal to 0, right? Cool? Okay. So now we will do reverse array. Reverse array. We'll take an array, and what we have to do is we have to return a copy of this array reversed, okay? So in my opinion, this question was actually one of the more difficult ones, because dealing with, just because it's throwing in the whole concept of dealing with arrays, right? So I feel like dealing with arrays is just like a little bit difficult, especially when you have to constantly make copies of things, right? However, let's start from the basics, right? So we need to define our base case, right? So if our base, just like strings, arrays are indexed, right? So the base case could probably be the same as the string, right? If the string's.length. But now I'll just do if array.length is equal to 1. If there's one thing in there, what can we do? We can just return array, right? No. We have to make a copy, okay? Because whenever you inside of this function, since we have to make a copy, you should always be copying it, okay, at every point in time, all right? So if there's an array of 1, then we can just return that thing, okay? Let's not even think about the logic behind the actual problem yet. Just, this is a common base case, right? So let's try this out. So now we're going to say let result array, right? And that's going to be an empty array, okay? Is everyone with me so far? So this is the thing that we're going to be pushing things into, right? So the first thing that we can do is we could do result array dot push array at array dot length -1, right? So that's the first thing we're going to do. Because if we were to solve this with a loop, we would just be looping from the back of the array and pushing everything into result array one by one. And then we'll have our reversed array. So our first step would be to just push in the last thing. So what do we do now? What do we do now? So now we have to get rid of that last element, right? We have to get rid of that last element and call the function again where it still passes in the last thing, right? So we can store this in a variable, let returned array equal to reverse array, and what we pass in is array dot slice of 0 to -1. So what this is going to do is this is going to start from the beginning, go until the end of the array, because it's -1. -1 hits the last element, and the stop index is not inclusive, so we do not include that element. So what we get now is the entire array except the last element, right? And then what do we do with this returned array? We could say result array is result array is now going to be equal to result array dot concat, because what does concat do? Concat returns a new array, okay? So concat with returned array. And then over here, we can return new result array. right? And we can even do this in one line. We can say return result array dot concat of reverse array and pass an array dot slice of 0 to 1 to negative 1, right? And then we can save these 3 lines. So what we do is every time, like we make our original array, our results array, which is an empty array, and we push in the last thing. So if we had an array of 1, 2, 3, we push in that 3, right? Because we want 3, 2, 1. So we push in the 3, and then let's comment this out and let's focus on this. So it looks like it's in 3 different steps, right? Then we are going to get a returned array. A result would be a return value of this function called again with everything from the beginning minus the last character. So this would be called again with array of 1, 2, right? So then in this function call, result array will have 2 pushed into it, right? And then we will call this again and we'll say array.slice of 0 to negative 1. So that'll just be an array of 1. And now when I have array of 1, the length is 1, so we can just return this value. So that means if that returns this value, then returned array will be 1, and then results array will be that 2 concatenated with that 1. And we need to store this in a variable here so we can concatenate it with what we have in our current result. Okay? Then we just return the result because it kind of goes back and back and back, and then we're good. Do you guys want me to do like the call stack thing and walk through what's happening?
On line 23.
On line 23?
Yeah.
You're lost here?
Yeah.
Okay. Let me run through the call stack thing. This really does help, okay? So if I call this with this with reverse array of 1, 2, 3, right? What happens? So is the array dot length 1? No, the array dot length is 3, right? So we skip this if statement, and then we have our result array. Our result array is just an empty array, right? And then we push in array at array.length minus 1. So that means it's 3. Okay? So now we go on to line 22. And line 22 is basically going to be, we're going to call our recursive case again, but we're going to pass in everything except the last element. And then here, what we're going to do is we're going to concatenate it into here, right? So what results array will be this dot concat of reverse array of 1, 2. Does this make sense? Like, forget about this. This makes sense here, right? What if we don't have this? This is this. Writing it like this is the same thing as this, right? So we're returning, what this is going to return of 1, 2, 3 will be bracket 3, which is what results array is currently, because that's what I made it on line 21, dot concat, and what do we pass in concat? What are we concatenating? Concat takes an array, right? So this has to return an array eventually, right? So we pass in a function call, but we pass in to reverse array 1, 2, minus that 3. So now this is paused, and now we have reverse array of 1, 2 on the call stack, right? So we run through this again. Is the array.length 1? No, it's 2. So results array is now going to be an empty array. And then we push in the last element, which is a 2. And then we return that dot concat with what? Reverse array, and we pass in 1, right? Because from slice from 0 to -1 will just give us the 1. So now this goes on the call stack. Reverse array of 1. So what does this do? If array.length is 1, we got it. We got the base case. We return from that function. This function returns on line 18, and we skip these lines, right? So we return array.slice because we are making a new array, a copy, right? So we return a new array of 1. So if this returns a new array of 1, we can take this off of the call stack, and then this will be 1, right? So what is array of 2 dot concat array of 1? 2, 1. So that means now this is being returned the whole time, a new array of this. So that means reverse array of an array of 1, 2 will return this, correct? So since this is returning, we can get it off, and this will translate to 2, 1. So 3 dot concat 2, 1 will give us 3, 2, 1. Does that make sense when I go through it like that?
Yeah, is there any way to, the array.slice return, how did you know to do that?
Because if you just return the array, you're returning that real array, right? So we have to always make a copy. So slice makes a copy, right? That's why.
Right.
When you hear copy, when you hear like make a copy of this array, think slice. Think, okay, let's make a copy, okay? I'll leave this here for you guys. Okay, now let's go over what is the last one you wanted me to do. It is palindrome. Is palindrome. So is palindrome is obviously very hard. Okay. This is a hard problem, right? Because it's kind of like, but not really. It's like, it's kind of hard because because what we're doing is returning a true and false, and we want to break our recursive case early if we ever find a false, right? So this is obviously going to be, it's not too hard, but it's definitely very different from the rest of the problems you were doing, okay? So let's think. What is the first thing we have to do, right? We have to think of a base case. That's the first thing we have to do. We know that we're going to have to go through this string in a weird way, like front to back, and go in like that. But when do we tell it to stop, right? When we solved this with a loop, we compared the last to the previous, and then went in, right? So when would be a valid place to stop? If string dot length is equal to 1, we can return true. Because if we have, an odd numbered string, that means when we're at 1, it has to be a palindrome, right? Because everything else should have been true. We haven't stopped. We got to this point, so it's true. Also, if string dot length is equal to 2, that means we can't go any further because there's an even number. So this we can just return. We can return string at 0 triple equals string at 1. So this will return false if they are different, and it will return true if they are the same, right? So these will be our two base cases, because depending on whether it's an even string or an odd string, we will hit one or the other, okay? Also, in the beginning, we can reassign string to be string dot to lowercase, just to handle any cases, right? Is everybody with me so far? Okay. So now we can say, now we have to check something, right? Now we have to check. This is actually kind of a third base case, but it has to do with the problem, right? We first have to check if string at 0 is triple equal to string at string.length minus 1. So if this is not equal, we return false, because then it can't be a palindrome. However, if it's true and we make it past this if statement, we have to go down. Because to check if something's a palindrome, you have to check every single letter. Because that's what palindromes are, right? So now we can do return. What we return would be is palindrome, right? Is palindrome our recursive call, and what are we going to pass in? We're going to pass in string, but we checked two things, right? So we pass in string.slice of 1 to -1. So that will get rid of the first character, and it will also get rid of the last character. And then we'll call it again and again until we hit here. And if we ever hit here along the way, then it will stop calling recursive. We'll never make it down to the end because we don't need to. We just return false. And to clean this up a little bit, right? Look at that. Beautiful. Any questions on is palindrome?
I was so close with all of these. So close and yet so far.
Yeah, I mean, it happens, you know? These are tough questions, especially, like, just thinking, I feel like when you're thinking of problems with recursion, I feel like it just requires a different way of thinking than normal problems, in my opinion.
I like the recursion versus the loops, though. Like, it makes more sense to me.
Well, you are one of a kind. Okay, so any other questions before we get started into Recursion 2?
Marco, you've got your REPL and you've got these Zoom recordings on YouTube, right? You keep your REPL on the Slack. You got the recording on YouTube.
Yeah, but the link to the YouTubes are in the Slack as well.
Okay.
They're all pinned to the channel. If you guys go to the top of the channel, there's a little pin icon. You click it, you'll see all the pinned posts. Okay. Without further ado, we'll get into Recursion 2. Let me capitalize it. Recursion. So, like I said before at the end of the lecture, you're done learning about recursion. That's all you needed to know. Recursion does not change, right? But now it is complicated, so I'm going to walk you through how we can use recursion to traverse through nested objects, okay? And arrays. So let's say I had let obj, right? And it's equal to this object, and it has a parameter a, which is another object, and it has a parameter z, which is 10, okay? And let's say inside of a's object, we had b, which was another object, and then we had c, which was another object, and then we had d, which was 5, and e, which was 50. Okay? This is a mess, right? Let's say I asked you to write a function that will take an object, and you have to get the sum of all of the values. But you don't know how deep it goes, right? So you could probably figure out a way how to do this with a while loop, but let's figure out how to do it with recursion instead, okay? So we can say function get sum, right? And that's going to be equal to, oh wait, when I go back and forth, I like merge how to do this always together when I'm defining functions. Because I usually just do it like this, but like I feel like some of you guys just like using the function keyword, so I try to do it that way, and then I mess it up and whatever. So anyways, we have our function get sum, and this is going to take an object, right? So the whole goal of this is a sum, right? The whole goal is a sum. So we could do let sum equal 0 right away, because that's what we're going to want, and that's what we're going to return. But how do we add everything? So obviously this is an object.
Let is spelled incorrectly.
Oh, thanks. So obviously we would have to traverse through this object, right? We would have to loop through the object, right? So we could do a for let key in obj, and we can loop through the object. So normally we would say if type of obj at key is equal to object, we can do another for in loop, right? However, we don't know how many times this is going to go, right? We don't know how many times this is going to go. So what we can do is we can say, well, before we do this, actually, let's think about this, right? So we know that if it is an object, we're going to want to loop even further, right? So this is probably where our recursive case is going to be, right? So if this is the recursive case in the if, then if it's not an object, we need an else, right? And what do we do with the else? Sum plus equals obj at key, right? Because if it's not an object, it's got to be a number, correct? So if it's not an object, it's a number, so we could just add it to the sum. If it is an object, we still want to add to the sum. We still want to add to the sum. However, what do we want to add? We want to add the return value of get sum, and we pass in obj at key. Because this is an object, right? And get sum takes an object. So we just checked if it's an object, so we can pass it down to get sum. Then, outside of the for in loop, we return sum. And this is how we do it. So, before we ask any questions on this, I'm going to walk through our call stack, okay? So our call stack will visually give you an idea of what is going on, okay? And maybe I'll get rid of B just to speed things up, okay? Rep will sometimes just stupid and annoying. Okay. Cool. So now I have A, C, D, E, and then Z on the bottom, okay? So, well, let's just see if this works first of all. So I'll console.log get sum, and I'll pass in obj, right? That's what it's called, right? What we get is 65, okay? Which is correct. So let's see. Let's see what happens on the call stack. So first off, we put get sum into the call stack, and we pass in an object, right? And what's the object we're passing in? It has A, which is an object, which has C, which has another object, which has D, which is 5, and E, which is 50. And then, outside of that object, outside of that C object, we have Z, which is 10, right? So this is what it looks like flat, okay? This object, A's value will be this, correct? This object. And inside of this object, we have a key C with this object as a value, right? And then we have two key value pairs in here. D is 5, E is 50. And then after the key value pair of A, we have a key value pair of Z, which is 10, okay? So let's see what goes on now. We say sum is equal to 0. So sum is 0. And now we say, now we do a for in loop. So we're looping through this object, right? We're looping through this object. So we do if type of obj at key, okay? So the key is going to be A. So object at A will be this, correct? So if object at A is triple equal, type of that is triple equal to object, it's true, right? That's true, right? Does everyone agree with me? Is anybody lost so far? So the object at key's type is an object because the key is A and its value is this object. So its type of is object, so we enter down here. So 0 is the sum, and that's going to be equal to plus equals get sum of that object, which is C, and then D, which is 5, and then E, which is 50, right? So hold on a second, we're plus equaling a function call, so this function gets paused, and then we put this on the call stack, right? We put this onto the call stack. So what is this going to do, right? So let's run get sum of this object. Let sum equal 0, okay, sum 0. Then we loop through this, and then we say if type of object at key. What is key? Key is C. So what is object at key? Object at key is this object, correct? Object at key is that object. So is the type of an object? It is. So we do sum plus equals get sum. And then what do we pass in? We pass in an object, D of 5, and E, which is 50, right? Now that we have another function call, this function call has to go on pause, and we'll add another thing to the call stack, which gets the sum of D5, E, 50, right? And what does this return? So let's see what happens. Sum is going to be 0, right? And then we loop through this object, right? So the key is D. If type of object at D is object, right? Is it? Not. That's a number. So we skip this if statement and we skip the recursive call. So that sum is going to be plus equal to object at key, which is 5. Okay? So now we have 5 as our sum. Now we continue the for in loop, right? Because after we do this, we hit line 62 and there's nothing else, but we're still inside of our for in loop. So we'll loop to the next key value pair. So the key in this situation is E. Is the type of object at E an object? No, it's not. So we do 5 plus equals 50. So that's going to be 55. Oh shit. 55, right? We skipped the recursive case again and went into our base case, right? The base case is essentially what blocks the recursive case from running, right? So even though this isn't first in our function, it's still acting in the same way, right? So now, wait a second. We hit 62, and we're saying, okay, next iteration. But there isn't anything else. That was the last key value pair. So we break out of our for in loop, and then this function call is going to return 55. So if that returns 55, then that thing that we were waiting to add 0 to, 0 plus equals get some of this, it's going to plus equals 55, right? So here, we were waiting for this, right? There was only one key value pair in here. So now the total in this situation is 55. And we finished this key value pair. Is there another one? No. So we break out of the for loop over here and we return 55.
What about Z? Isn't Z 10?
We haven't hit Z yet, right? Because we originally started looping through A. I'll get to that in a second. So now, does everyone agree that this returns 55? Right? It carried it down. So this returns 55. So I'll take that off of the call stack. So if that returns 55, then this is actually 55. And I do 0 plus equals 55, and we get 55, right? And this is what was happening here when we were looking at this object on line 59, right? So now the total is 55. And since there was only one key value pair in there, that returned 55, right? So then, that went into the if, line 59 finished running, so we skip over the else and continue the next iteration. What is the next iteration? Z and 10, right? So now we do, is type of object at Z equal to object? No, it's a number. So we skip the if, go into the else, 55 plus equals 10. So we get 65. There's only two key value pairs, so once we finished with that key value pair, that was our recursion, and then we did the last one just now, we can finally break out of this for loop and return 65. And that's that. Any questions? Okay, cool. So now we'll dive into the slides. Okay? So let's look at this example quickly. Logs an array, right? So logs an array, takes in an array, it does a for loop, it loops through that array, and then it console.logs each element. But what if the input is nested, right? Consider element on line 3. That could be a number, or it could be another array. If element is an array, we want to log every number inside of it, right? So if only we had a function that takes an array and logs out all of its values. Wait a second, we just wrote that, right? So if we just did this, we would do 1 and then array 2, 3, right? But we want to log out that 2, 3. So what if we did this? We loop through the array, we store our current element into this variable element. We check to see if it's an array. If it is, we'll call logs an array again and pass in that element. Else, we will just console.log that element. So if we pass in logs an array of 1 and then array 2, 3, logs an array of 1, 2, 3 goes onto the call stack. Once this is on the call stack, we skip this if statement and go to the else for the first element because its type is a number, right? So array.isArray should return false. So we get 1 in the console, and then we go to the next iteration, right? So we'll have 2 and 3. Wait a second, array.isArray of element. This array is an array, so it will return true. So it will do logs an array of element, and then that goes on to the call stack, right? So now we have logs an array of 2, 3 running, so we'll get 2 because we're now looping through this one, and nothing inside of here is an array, right? So we will never hit this if condition when we pass this in. So at the very end, after 3, this is finally done running because we break out of the for loop, right? So then this goes off the call stack, and then this is finally done running because we finally made it past this if. So we skip this else, else, and that's the last element in the array, so they get off the call stack. Right? This is like the same thing I just showed you, except with arrays. We're not returning anything, but we're just console locking. This is how you go through and touch each element inside of an array using recursion. Inside of a nested array using recursion, okay? So instead of type of equals object, we do array.isArray, because that's the only real way to check if something is an array, because arrays types are object. So let's do this example of concat elements. So it takes an array of elements, we'll say every element is a letter, and concatenates them together. So array of ABC should be ABC. So let's say we have our final string, which is an empty string. We loop through the array, and we say final string plus equals the current element, right? And then we get the final string. So if we pass in ABC, we will get ABC, okay? So let's look at this. Let's say we change this function to take in nested arrays. So it starts off the same way, like we have a final string, empty string, and we have our for loop because we just have to loop through it, right? That's just how we do it. We take our current element, and then we check to see if that current element is an array. If it's not an array, if this if statement is false, we just add that thing to the final string because we know it must be a string, right? However, if it is array, we still have to add something to the final string, so we do plus equals the function called with that element, because that inner element is another array. So let's see what happens on the call stack when we pass in A and then an array BC. So this goes on to the call stack, concat else of one array with two elements inside, string A and the array with BC, okay? So the final string is now empty string. So we loop through this array, we check to see if A is an array, it's not, so we do final string plus equals A, correct? So that means final string is now A. Is everyone with me? Now, we continue our for loop. Now I is 1. So when I is 1, we'll do, what is the first index? It's an array, right? So element will be this array of BC. Array.isArray of that element, which is an array, that's true. So this is going to be, this A now is going to be plus equal to concat else of BC. So now concat else of BC goes onto the call stack. So we do our let final string equals empty string, and we loop through this array. Is B an array? No. So we do final string plus equals B. So final string is B. Then we continue our for loop. Is C an array? No. So we skip this if statement and we go into this else. Final string, which had the B, is now plus equals to C. So now final string is BC. That was it. The for loop now stops, and once we exit the for loop on line 11, we return final string, right? So now that concat else returns final string, BC, we can take that off of the call stack, and now we were waiting for that to finish, and it just returned BC, and we were waiting to add it to our final string here. So final string of A is now going to be plus equals BC, which gives us with ABC. And that's what this function returns. And we take it off the call stack. Cool? Any questions on concat elements? All right. And we get this. ABC. Nested objects. So, spoiler alert, this is going to be the same example I just showed you. So working with nested objects is very similar to working with nested arrays. And you can see that, right? We use a for in loop to iterate through the object, and if the value is another object, we recursively call the function on that nested object, right? So we have some vals, and we pass in an object with two key value pairs, A to 10, and B to 20, right? We have our sum here, we loop through that object, and we add that value to the sum, and then we return sum. So we'll get 30, right? This is easy to do if we don't have a nested object. If we do have a nested object, what we get is something a little different. So let's say we have A is 1, and then we have B to C to D to E to F3. So this one goes even further than the example I showed you. So the first thing that happens is we pass some vals this crazy object, right? So right now, the sum is 0, and we start looping through this object. First, we get to the key of A. And what is the key of A's value? It's a 1, right? Is that type an object? No. So we go into this else, and we say the current sum, which is 0, is now plus equals to 1. So the sum is now 1. And we continue our for in loop, because that's what happens after line 9, right? We continue our for in loop. Now, we hit B. B's value is an object, right? So we're going to pass this if condition, go to line 6, and we're going to say sum, which is 1, plus equals some vals, and we pass in this object, right? So now we have another function call. So that gets thrown onto the call stack, okay? So now we have C, D, E2, F3, right? So we do our for in loop, we initiate sum at 0, and we say, okay, is the type of the object at key, so the key is C, is object at C an object? It is, so we go into line 6. Sum is now plus equals to some values of that object, right? So now, since this is 0 plus equals some values of that object, we'll throw that onto the call stack. So we start running this function. These functions are paused, right? These are paused while this is still running. So now we initiate sum again at 0, and we loop through this object. The current key is D. Obj is this object. So this object at the key D will give us this object. Is that type of an object? It is. So we hit line 6, and we do some value, 0, the total, 0, is now going to be plus equals to some values, and we pass in this object, right? So now we put something else onto the call stack. We put some values of this object, which is E2 and F3, right? So we set sum equal to 0, and we start looping through this object. Object at E is 2, right? So its type is a number, not an object, so we skip this, and we go into this else. So sum is now going to be plus equals to 2. So the sum is 2. Now, we go to the next iteration. The next iteration, we look at the key F. What is the key F's value, right? What is the value of the key F? It is 3. 3's type is not object, so we go into the else. We do 2 plus equals 3, which gives us 5. That was it. There were only 2 key value pairs inside of this object. So that means we never hit this recursive statement inside of that for in loop, so we can just break out of the for in loop because we've hit every key value pair. Then we hit return sum. So this returns 5, correct? If this returns 5, that means this over here returns 5, right? Because this is the same thing. So that means where we were waiting to add to 0 is actually 5. In this function call, we were doing 0 plus equals 5. And since there's only one key value pair in here, we break out of the for in loop and we return this sum of 5. So now since this returns 5, we were waiting for that to return, so it returns 5, so we can add it to the sum in this situation, where the sum was 0. So 0 plus equals 5, we get 5. This one also has only one key value pair. The C's key the key C, its value was this entire object, okay? So that means we break out of the for in loop. Only one iteration, right? So that means when we break it out, we return sum, which is 5, right? So since this returns 5, this returns 5. And we were waiting for this to return 5 the whole time. And this is the second iteration in this function call, right? Because we already checked A and we put 1 into the total. So now we were checking this. And we got down from deep inside of this object through recursion, we took 5 from the depths, right? And now we spit it back up and we add it to the total. And now, since this was the last key value pair inside of this object, we can finally break out of our for in loop and we can finally return sum, which is 6. And then we can finally take it off of the call stack and we can finally see 6 in the const. Any questions on this? This is the same as this. Someone ask me questions. All right. That's it, guys. That's it. Oh, thank you. I'm flattered. No, honestly, it's been a pleasure teaching all of you. So I'm gonna do the breakout rooms one last time. You know, if you guys want, you can come back in at 5. Again, I'll stay until 5:30, and you can ask me any kind of. It's not required. Otherwise, go enjoy your Sunday. It's not required, but you can ask me any kinds of questions you want. After 5 o'clock, I will open practice assessment 1. Okay? And then look out for the solutions like tomorrow or something, or maybe the day after tomorrow. I don't know. But try it before you see the solutions, okay? But yeah, I'll stick around till 5:30 if you have any concerns about the process, any questions about what it's like being a developer in the real world. Yeah.
Marco, the